If a scatter plot indicates that there is a linear relationship between the independent and dependent variables, then the next step is to fit a line to the data. There is one line which gives the best fit and is called the line of best fit, regression line, or the least squares line. The equation for the line is actually determined using calculus. This process to determine the line of best fit is called linear regression. The bivariate data is shown in a scatter plot and the line of best fit for the following data. The line of best fit was calculated using linear regression. We will be using our calculators. The regression equation has the format y hat equals a plus bx. For the example on the previous slide, this is the equation. Y hat equals 43.768 plus 2.772 times x. The variable y hat is the y coordinate of the point on the line. It's the estimated or predicted y value. Data points have the format x, y, and points on the line of best fit have the format x, y hat. To calculate the line of best fit, calculus is actually used to minimize the sum of squared errors. We use our technology, our TI-83, for this process. To calculate the SSE, you have to find the distance between each y value from the data and the estimated or predicted y value, square each distance, and then add them together. The SSE is a special measure of how much the estimated or predicted y values on the line differ from the actual y values. If a scatter plot shows a possible linear relationship, then the correlation coefficient indicates how strong the relationship is between x and y. We use the letter R for the correlation coefficient. If R equals 1 or R equals -1, there is perfect correlation. This means that the points are already in a straight line. In the real world, perfect correlation is very unlikely to happen. The closer R is to 1 or -1, the better the correlation between x and y, because the data points are closer to the line of best fit. Take a look at the scatter plots shown here to see what a strong negative correlation and a weaker negative correlation look like. Next, let's talk about facts about the correlation coefficient. There's positive correlation if x increases, then y increases, or if x decreases, then y decreases. If there is positive correlation, then the line has a positive slope. Negative correlation, if x increases, then y decreases, or if x decreases, then y increases. If there's negative correlation, then the line has a negative slope. There's no correlation if the correlation coefficient is 0, r equals 0. This means there is no relationship between x and y. If there is no correlation, then the slope of the line is 0. High correlation does not necessarily mean that x causes y or y causes x.